The generation of curves can be a very complex operation if you are designing ships or car bodies, for example. It can also be a relatively simple operation if you only want to place a curve through a series of points when tracing a contour line on a map or a site plan. As you would expect, MicroStation has a wide range of curve placement and curve editing tools that will allow you to place almost any conceivable curve. Now, the purpose of this set of videos is to briefly touch on some of the simpler curve tools that might be required by the average user. Curves are a very complex operation, and if you need more complex tools and techniques, then the help files are actually quite helpful. First thing to do is to locate the various curve tools. And the first one to look at is the linear toolbox. And here we see the curves tool set. I'm going to float the linear toolbox so we can see that a little clearer. This is the Create Curves tools, which we'll take a look at in more detail very shortly. Next to it is the Place Stream Line String, and let's just have a quick look at this. Note the information in the Tool Settings window. I'm not going to get into details about this at this point. Simply click and drag the cursor, then data point again to stop and right-click to stop the tool. It doesn't look much like a curve as you would normally define a curve, and in fact if we zoom in very close to this line, you'll see it's made up of a series of line segments. Segment, 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 etc., etc. So this is not a curve tool. So I can undo that and ignore it from now onwards. The third tool here is Place, Point, or Stream Curve. So this is a curve tool, and I'll start that. But notice the Tool Settings window, it looked like the previous tool with the option of either a stream or a point. Well, the points are what we've just done, so we need to do a stream. So in effect, this is a sort of multi-purpose tool. It does either the line strings or the stream curves. So let's place a curve, and again, it will look very similar to the last one that we just did. Right-click. But now, if we zoom into this, we'll see that it is actually a set of curves. We don't have line segments here. Everything is curved. So technically, it's a curve. But for most practical purposes, this is not a very useful tool. So I'm going to get rid of that. So of course, feel free to experiment with those two tools. Let's go back to the main Create Curves tool set. Now I'm going to float this toolbox on its own. So here we see the Create Curves tools. Both of these are highlighted since it's the same tool. But now we see the remainder of the curve tools that are available to us. Now while we're at it, go to Tools and Curves and open that as a toolbox. We'll see a different set of curve information. But again, note that we still see the same basic curve creation tools highlighted. They're obviously all the same. Now we have, in this one, we have editing tools. Modify curves, modify B-splines, and curve utilities. So that one from the Tools, Curves toolbox is mostly for editing. This one, in expanded form, is for curve creation. So you don't have to float this particular toolbox. You can simply data point and hold on that one to see exactly the same curves. I've just floated it for convenience. Now, curves can be generally placed in three different ways. You can place a curve by snapping to points, and points we'll be discussing a little later in the next series of videos, or to element vertices. So we could snap a curve to the various element vertices on this line, for example. We could create a curve by snapping to an element, which would be this element, or we can enter data points using AccuDraw. Now, for convenience sake and quickness, I'm going to use this line string that you see on the screen, and I'd like you to draw something similar too. It's a simple connected line string, so use a Place Smart Line with lines connected. And for visibility, use a dashed line style, as I have done. And scale is not important. It's merely a line string. Now let's start by looking at the tool settings window and look at the methods. We have 5 methods to work with: control points, through points, which makes more obvious sense since you can place a curve which goes through various points on elements or points placed in the screen, and other methods which you may or may not be familiar with. Let's start with through points, which is a fairly simple thing to understand. Input, we can pick a line string, which is what I'm going to do because that's the simplest way to do it, or we could use points, in which case I would have to snap to each of the vertices of this line string. We'll go back to picking line string. I want to keep the line string because I'm going to keep using it. My closure is open, meaning that I have a curve which has 2 ends to it, a start and a finish. It could be a closed curve, which means that the curve will come back to its starting point. We'll leave that on open. And tangents, we'll say none at this point because we're not trying to be tangent to any particular existing line. Now all we have to do now is simply select the line string. I'm going to use a series of different colors so we can differentiate between the different methods. So simply pick the line string and accept the curve. And the green line is my through points B-spline, because if you notice, we are actually placing B-splines. Note that the curve does follow through each of the vertices of the line string, which is exactly what we want. Let's try a different method. Let's use control points. We'll pick the line string. Notice that the information has changed. There's now an order. The default order is 4, and I'm going to replace that 6 with a 4. You'll see what happens in a second. Let's try this again. So now I'm going to select the line string. Let's use a different color. Let's go to red. Select the line string, accept the curve, and notice that the curve is different from the through points. In fact, the curve does not go through the points, through the vertices of the line string. This is the type of curve that it is. Notice too that we have control points now displayed. The original dash line is highlighted, and we have red dots, which are the actual control points. Now these assume more significance in a 3D drawing, but you can actually edit the curve by manipulating the control points. Let's try a different one. We'll use Catmull Run. Notice that the tool settings window information is very simple at this point. Change the color again. Let's go to yellow. Select the line string. Accept the curve. And it's yellow, so if you look very carefully, you'll see that the curve is similar to through points, but not quite. The curve does not necessarily go through the points at all. We also have a set of control points, different control points for this curve too. So you can start to see how complex this can be. Each of these types of curves produce a different shape of curve. And you really have to know what sort of curve you're looking for before you start this process, which again requires you to know the type of curves that you need for a particular project. Now, I'm going to leave you to experiment with the various methods in that particular tool set, but I'll just leave you with a thought that in general practical terms, if you were drawing contour lines on a map or a site plan, for example, you would likely either select the through points or the Catmull ROM B-spline methods to connect the elevation points. Both of these methods project the curve through data points and provide an accurate approximation of a true curve. Now let's move on to another tool. I'm going to zoom that out of the way. And I want you to draw, first of all, a rectangle. I'm going to draw this in 0 and just need the block tool. Any rectangle will do. Going back to 1 for the line thickness. Let's have a look at the conic curve. I'll start that tool and select as the type parabola. Input by points, and let's select the bottom left corner first. Then we select the bottom right corner, and then we select the midpoint of the upper edge there and place our parabola. Now on your own, try the other methods. the hyperbola and the ellipse. Use the same rectangle or make a different one. Now you might be wondering why you perhaps are not seeing the control points. The answer to that is simple, although a little obtuse. Go to Element, and the first item is 3D and B-spline. Select that, and here you'll see the control mechanisms for curves and surface visibilities. Now in my case, I've got curved polygon as visible. If I take that off and make it invisible, and if I go back and redo this parabola, there, there, and there, now I don't see the control points. And for most operations, this is really what you need. It's only when you need to see the actual control points that you need to actually display them. So either leave that curved polygon invisible, as yours probably is, or make it visible to see the curves as I've shown them so far. Let's take a look at one more tool. I'm going to look at the Spiral Curve tool, which will draw a spiral, as you might think. Before I can do that, though, I need a couple of lines to give me precise direction. So I'm going to zoom out a little bit here and move over. Start the line tool. I need two lines. First one is this way and will be 6 master units. So whatever master units you're working in, just type 6 and data point. And I need a short line in that direction. Length doesn't matter. Now that line can go in that direction or that direction, as you'll see in a second. Now let's start the tool. And I want you to make the settings I've shown here. First of all, use the Archimedes spiral. Set the initial radius to 5 master units, the final radius to 10 master units, and the angle to 715 degrees. And then we follow the inputs for the actual tool. Now notice that in the prompt line, it merely says enter start point. Well, you need to know that we have 3 points to select, and the vertice here is point 1, the end of the short line is point 2, and the third point is the end of the long line. So that's 1, 2, and 3. So click on point 1 and point 2 and point 3 and right click, and there's the spiral, which in this case is clockwise from the inner part of the spiral. On the other hand, if I undo this and do it again, but this time pick that as 1 and 2 and 3, 1 and 2 and 3, same spiral, but now it's counterclockwise from the center. Now the spiral is moved over in relation to the two lines because I didn't draw a short line on the left side of the 6 unit vertical line, which would have moved the spiral over to the center. Experiment with that. It's quite fun. Change the radii, change the angle too to smaller and much larger values to see the effects. And also, of course, try the other 2 methods of drawing a spiral. You might also have a look at the various other curve tools. Be warned though, some of these are actually 3D tools and won't work in 2D.